Yeah, please limit the noise. We're on problem number 24. Mr. Quinton, can you read number 24? Quinton, can you read number 24?
What is the period of a 1.00 meter long pendulum?
Okay, so the length of the pendulum is given 1.00 meters. And we're looking for the period. Period is, what is the equation for period?
Is that 2 pi and the square root of L over G?
Okay. So the period will be 2 pi square root of, what is L? 1.00 meter. What is G?
9.8.
9.8 meters per second squared. So if you simplify this, you will get 2.01 seconds. Okay, so that's number 25. Let's move on to number 20, sorry, number 24. Let's move on to number 25. Unless there's a question on 24.
I think my question is, where did you get the numbers from for L and G?
Well, the number 24 says, are you on number 24? Can you read it for us? Kayla?
What is the period of a 1 meter long pendulum?
Okay. So what's the meaning of 1 meter long?
Well, I see long is 1 meter, but G, what is G?
Okay, G is the acceleration due to gravity, which is a constant.
G will always be 9.8.
Yes, G is,
Okay, thank you.
for all problems on Earth, G is 9.8. Unless the problem specifically says calculate the period of a pendulum on the moon, then you will need to know the value of G for the moon.
Okay, we haven't gotten to that problem yet, have we?
Say it again?
We haven't gotten to any of those, have we?
No, we haven't. But if you came across that kind of problem, then they'll give you the value of G for the moon.
Got you.
But we know that for Earth, G is always 9.8. So if a problem doesn't say a different planet, then you always use 9.8.
So why did we use 9.8 in number 22?
Because it was also G on the Earth.
I'm confused.
Number 22. You said, why did we also use 9.8?
No, why didn't we? Because we didn't, did we?
We did.
Okay. I don't have that in my notes.
Okay. We said T squared times G divided by 4 pi squared. And G was 9.8. T was 0.500.
Okay.
The
And that's
length,
how we got 6.21.
yes, and the answer was 6.21 centimeters.
Okay.
Okay, so read number 25 for us.
Okay. How long, well, hold on, my computer is crazy. How long does it take a child on a swing to complete one swing if her center of gravity is 4 meters below the pivot?
Okay. Now, I'm sure many of you will be intimidated if you read a problem like this because there is a lot of, intimidating terminology. First of all, it's a swing. There is a time pivot. There's a child. So it's easy to get intimidated or to think the problem is very complicated. Now, can somebody tell us how to proceed with this kind of problem?
Okay, so with the fact that we're given M and
That's it. Just M.
We're given what?
But M is, will it be M double? Once you double M, like times 2, if you
Why?
swing. Hold on, wait. How long does it take a child on a swing to complete one swing? So does she pass by 4.0 twice? I don't know.
for this one, will we use the same equation for the simple
Okay.
pendulum?
Those are all good questions you're asking. Let me make a sketch, okay? So this is the child on the swing, okay? And the pivot point is here. That is where the swing is hanging from the support. So the distance from the pivot point to the center of gravity is where the mass of something is concentrated. So that distance is 4 meters. So how is this problem different from the one we just did, number 24?
We were given the distance, we weren't given the period.
I said, how is this problem different from number 24?
Because instead of, well, like I said before, wouldn't it be the fact that we were given the length of the, well, that's our center of gravity.
Well, what I'm trying to say is number 24 is exactly the same as number 25. The difference is that your length is now 4 meters.
Yeah, that's what I'm saying. Like we were,
yeah.
L,
So your period is 2 pi L over G, the same as number 24. So instead of 1 for number 24, you're going to use 4 in this problem because the length of the swing is 4 meters. That is, the weight of the child is concentrated 4 meters below the swing, below the pivot point. So 2 pi square root of 4 divided by 9.8. Okay. So even though this problem looks kind of complex, it's really just a pendulum. You can treat the child as a mass attached to the end of a string, swinging back and forth. That is a pendulum, right?
Right.
Because the pendulum looks like this. You have a mass, length, and this mass swings back and forth. That's what we call pendulum. So if you have a child sitting on the swing that is swinging back and forth, if you know where the weight of the child is concentrated, the distance of that point to the pivot point is the length. Does that make sense to everyone? Okay, so this is an application of what we just learned. Okay, number 26.
So that's the answer? We don't solve the square root of
The
both.
answer is 4.01 seconds.
Say that again. 4.01 second.
Yes, 2 pi square root of 4. So that's 4.01 seconds. So your L is 4. And for a pendulum, you don't really need to know the mass. You just need the length, because the period is 2 pi length over gravity. So somebody read number 26 for us.
The pendulum on a cuckoo clock is 5 centimeters long. What is its frequency?
Okay. How do we proceed with that kind of problem? We know the pendulum is 5 cm long. Again, you need to convert this to what?
Meters.
So 1 meter is equal to how many centimeters?
1,000.
Okay. So that would be 0.05 meters. Okay. That's just a conversion. So we know the length. How do we find the frequency?
So we found the time period, and then from the time period, we found the frequency.
Okay, so frequency is one of the time periods. So you could do like Amina suggested, find T and then find 1 over T. Or you could directly say that F equals 1 over T, which is equal to, if T is equal to 2 pi square root of L over G, what will 1 over T be equal to?
1 over 2 pi square root of L over G.
No. Square root of.
Oh, it's G over L.
You have to flip both sides. Remember, you have to flip both terms. So 1 over L over G is the same as G over L. Does that make sense?
Mm-hmm.
Okay. So that way, this is 1 over 2 pi square root of 9.8 over 0.500 meters. And this is 2.23 hertz.
Is that 0.500 meters?
Yes. And that's because the length was given to 3 significant figures. So that's why I kept 2 zeros after 5 to maintain the 3 significant figures. Okay, let's go to chapter 17. let's quickly look at sound and waves.
So, Dr. Natam, for
Yes.
chapter 16, would that be the bulk of the questions that we could expect to work on?
Well, these are the representative problems, and like I promised, I will still post a complete list of the suggested problems you should focus on.
Okay.
Yes, by the week before the week runs out, I will.
When is our exam?
That information will be sent out also probably tomorrow in an email, in a class email.
Okay.
Yeah.
And we won't have any problems that we didn't go over during these study sessions, correct?
Well, that's not correct, but you won't have any problem that is not similar to what we've sent.
Yeah, I'm not saying the exact same numbers, equate the numbers, but I'm saying the same format.
Yeah, and it's possible for you to have a problem similar to what you've done sent in your assignment or the quiz or this session. So the test will not be limited to just what we do in this session. Does that make sense?
Yes, that makes sense.
So yeah, question to the
Well,
quiz.
how long are these study sessions?
Say it again.
How long do we do Zoom? Like, what's
Well,
your
this will be one. This is supposed to be 1 hour, but I will extend it to about 15 minutes.
because I still want to go over the assessment, those problems that are on
Yeah,
there.
you can schedule separate let's say appointment with me during the week, and we'll look at that.
Okay, but not today.
Not today.
So,
Okay.
Dr. Natam, when it comes
But we'll definitely have another class session before this week runs out to look at problems from chapter 25, the problem on optics.
Okay, so for like conceptual questions, will we have a chance to go over those as well?
What do you mean by conceptual questions?
Well, applying the knowledge behind the problems. Like, will we have conceptual questions on our test?
Yeah, the test will be multiple choice, and it could the questions could be work out like what we're doing. They could be conceptual, yeah, like define something or explain this, or just qualitative reasoning.
Yeah, can we, if possible, the next time we have that, or if I have to schedule an appointment, can we do concept?
Okay, I mean, put some conceptual problems in the next session, but definitely throughout the week, you're welcome to ask questions. You're welcome to,
But what do we have the same questions though?
say it again.
What do we have the same questions? Like that's why we ask them here. So like most of the class will hear this, know what's going on too, instead of like
Yeah,
appointment.
but what I'm saying is most of the whole class doesn't study at the same pace. So there are certain things that many people just read and understand. So, but not everybody understands that way. So, if there's certain things that you're struggling with, it's best to do it one on one on me, because if I constrain everybody, to listen to a problem, everybody may not be facing that problem. It may be boring to some people because they already understand that. But I will definitely include some conceptual problems in the next session. Okay.
Okay.
But it's not possible for us to cover every possible problem in this session. That's why it's important for you to indicate what you're struggling with throughout the week.
So you're only doing one session a week as far as class sessions, and the other one are private.
This week we will have 2 because we didn't do something last week, but from next week we will have just 1 session per class.
And then we'll have the study session, right?
Yes, we'll have the study session before the test.
Say it again.
We will have a study session, yes, before the test.
So we meet twice a week, basically.
We meet once a week. We're doing twice only this week because we didn't have a session last week.
So this session right here wasn't optional, it was mandatory.
No, it's optional. I mean, we're not supposed to meet if you're not facing problems in the course. So it's optional.
Okay, can we move on to next?
This is again, this is a completely online course. That means students work at their pace. If they run into problems, then they contact the instructor to guide them past that problem. However, given the fact that physics it requires a lot of problem solving, that's why I instituted this, online problem solving sessions. If there's a student in class who reads and understands this, they don't need to attend these sessions as long as they are understanding material and they're able to complete the quizzes, the assignments.
With the test, do we take them all at the same time or do we take them at our leisure?
Well, the test, I will also include that in the email. The test, there will be like a window, let's say 4 or 5 hours within which the test could be taken. So I'm giving that window because if I just gave one time, it may not work with everybody. So I'll give like a window of 5 hours, let's say 2 p.m. to 7 p.m. And then within that time, each of you will have to schedule an appointment with Proctor U, at the time during that window that works best for you. And then they will contact you, verify your identity, and then they'll give you the password to unlock the test, and then they'll monitor you for the 50 minutes while the test is going on.
Okay, can I move on?
Yes.
Are you gonna make sure that you tell us like when we're gonna take our test way ahead? Because if we schedule our test less than 72 hours before we take it, they're gonna charge us more money. So,
no, I will tell you at least 1 week to the date.
Okay.
So you will have time to set up, but you guys need to go ahead and set up a Proctor U account, okay? And then once the test is set up, then I'll let you know so you can go ahead and schedule your appointment. But we will have like a time window, not just 1 hour, but like, around 5 hours during which everyone can take the test. Okay?
All right.
So let's proceed to chapter 17, starting with number 2. Mr. Quinton, since you're speaking, can you read number 2 for us?
What frequency sound has a 0.10 meter wavelength when the speed of sound is 350 meters per second?
Okay, so we have the wavelength.
Hold on, what page is that on? Was that all at the end of the chapter?
It's on page 685.
Thank you.
Okay, so we have the wavelength is given as 0.10 meter. The speed of sound is 340 meters per second. And we're looking for the frequency. So what is, which equation relates The wavelength to the speed of sound.
Oh, V equals frequency times wavelength.
Okay, so we're looking for frequency. That means frequency equals V over wavelength, right?
Mm-hmm.
So the frequency will be 340 meters per second divided by 0.10 meter. Which is 3,400 hertz. Okay. Any question? Number 3.
Can you pull that? Can you pull that back up?
No, this is recording, so I cannot go backwards. But what we did, we said the frequency is equal to speed over wavelength, which is 340 meters per second divided by 0.10 meter, which is 3,400 hertz. That's what we just did. Again, these videos will be available to you. You can watch it, you can rewind, you can fast forward.
Oh, is this, you just wrote it for me? Is this what it was?
Yes, I just rewrote it because I
Oh,
cannot
it's
go
so nice.
backwards.
Okay, hold on, wait. Let me write this down. Thank you so much. Okay.
Okay, number 3.
Oh.
Tiffany, can you read number 3?
Calculate the speed of sound on a day when a 1500 hertz frequency has a wavelength of 0.221 meters.
So the frequency is 1500 hertz. Okay, and the wavelength is what?
0.221 meters.
Okay, so the speed is the speed is
You multiply them, correct?
frequency times wavelength, yeah.
Yeah.
So 1500 times 0.221, and that will be 31.5 meters per second. And since we have to keep only 3 significant figures because of the 0.221, you will write this as 332 meters per second. Okay? So always pay attention to this. Pay attention to the significant digits. This number has 3 significant digits. So when you use it in a calculation, the answer cannot have more than 3 significant digits. So you have to keep only 331. But since the last digit to be discarded is 5, you're gonna round it up to 1 and add to the last significant digit. So you have 332. If the last digit was less than 5, let's say if it was 4, then the answer would just be 331. Okay, number number 5.
Show that the speed of sound in 20 degrees Celsius air is 343 meters per second as claimed in the text.
Okay, so this show that the speed of sound is 343 meters per second at 20 degrees Celsius. Okay, so what is the equation that relates the speed of sound to temperature?
Hold on just for a second. Okay. Speed of sound equals 300, well, it's based from the text is 331 meters per second times the square root of the temperature in Kelvin divided by 223 degrees K.
Okay, that's the equation.
Oh, sorry.
Okay, so 20 degrees Celsius is the same as how many Kelvin?
293 degrees. Well, K.
Okay, so T, the temperature in Kelvins, is equal to the temperature in degrees Celsius plus 273. That's the equation we use to get the 293. So you need to know this. You need to remember how to convert from Kelvins to Celsius and backwards. Is everybody on the same page?
Yes.
Okay. So once we've converted this to Kelvins, we just need to plug it into the equation. So where we have T in Kelvins, we're going to replace it by 293. So the V will now be 331 meters per second, square root of 293 over 273. And that will give you 343 meters per second. So you've shown that the textbook claim is correct. Okay, so the speed of sound at 20 degrees Celsius will be 343. Okay, so let's go to the section sound interference and resonance, the standing waves in air. And we're going to begin with number 38. Could somebody read number 38?
A showy custom-built car has two brass horns that are supposed to produce the same frequency but actually emit 263.8 and 264.5 hertz. What beat frequency is produced?
Okay, so beat frequency is the phenomenon called beats in physics refers to what happens when you have, let's say, two sound or wave sources have, different frequencies. So the beat frequency simply refers to the difference between those two frequencies. So F beat is equal to the absolute value of F1 minus F2. That's the equation. So in this case, F1 could be any of the two. It doesn't matter because you have the absolute value. So 263 minus 263.8 minus 264.5. And that is 0.7 hertz. Okay, so if you ask to find the beat frequency, it simply refers to the difference between the two frequencies. So what I'm saying is, if you look in this, if you look at 39, 40, and so on, they're all talking about beats. So you apply the same equation to solve those problems. But we can do, every possible problem. Okay. So do not limit yourself only to the problems we did in this session. Use what we've done to solve the problems that are similar but have different numbers, or they're slightly different.
Okay, was this section the last section we were going to work problems from in 17?
Yes.
Okay, 30, 38, 39, and 40.
40, 42, 43, those are also
like 38.
Yes.
Okay.
Not like 30, but there are things you need to know, like to find the frequencies of the fundamentals, the overtones, and so on. So those are things that are applicable. But our session is ending in a minute, so we will stop here tonight, and on probably let's say
Thursday.
Probably Thursday. Yeah, probably Thursday we will have another session. It may start earlier. How many of you are available in the day on Thursday?
Like, what's the day? What time?
I mean, the afternoon before 5 p.m.
No.
Okay, because I have an appointment 6 to 8 p.m. on Thursday. So we could meet even early in the morning.
So what about Friday or Wednesday?